Hey class, and welcome back. I wanted to give you a brief introduction to what you're going to be doing in lab number 3, where we're going to investigate Newton's 3 laws of motion. So there's 3 parts to this lab, part A, B, and C, each of which deal with a different one of Newton's laws of motion. So quickly, let's talk about the equipment that you're going to need. For part A, it's a briefer lab portion, and it's really just kind of experiential and observational. So all you need is basically a cup with some water in it. I would encourage you to get even like a bigger jug if you have one, like a big pitcher or something, but get something plastic, preferably something clear so you can really see how the water acts as you move it around in different ways, as the lab explains. And then you'll also need something like a note card, or even just like a piece, like this is just a piece of cardboard or something small like that. A small mass. I have like a nut that I just found in the garage, or a washer, or even just like a penny or a nickel or a quarter or something. And then a cup as well that you can either put water, or I actually just put a napkin in here, because what you're going to do is you're going to observe Newton's first law, the idea of inertia. Put the cup onto a surface with the card over the top. You're going to try to see if you can flick the card away and watch as the nut falls straight down. So that might be a little bit of a spoiler alert there for you, but that's part of what you're going to be doing in lab 1, or excuse me, part A of today's lab 3, but part A of lab 3. Okay, so that's what you need for the first part. Part B now, you're going to need a couple of those spring scales, so hopefully you have acquired these if you don't have them yourself. Here I have one that goes up to a total of 10 newtons, as you can see, and one that goes up to a total of 5 newtons. So I want 2 different values, preferably 5 and 10, but you can use other ones as well. You're going to need a pulley here, and then I just found some string we had laying around, so I made a little string that goes over here. You can also take it out and use it for other parts. You'll probably want one that's kind of shorter like this, and then you're going to want to tie another one that's quite a bit longer for part C of the lab. And then you need something to make different masses. So I just found a little plastic cup I had laying around, and I taped a piece of string to it. So here's a little cup, and now I can take and just add different nuts or bolts, or even pouring water or salt or sand, or really anything that you have around to make it a different value mass. I give you some approximate values for masses in this lab, but really you don't have to use that exact value. You can make your own based on what you have. So I have enough here. If I put all of these in this cup, all of these different nuts and bolts and washers and things, all of this adds up to about 500 grams, 400 to 500 grams, so just under 5 newtons. And again, when you're not sure exactly how much mass you have, that's part of why we have the spring scales. So here I just put some of these on. I hang it on my spring scale, I pull this up, and look at that. It's almost exactly 4 newtons worth of weight, or if I look at the other side, it measures the mass, and it's just over 400 grams. All right, so you'll use this to measure the mass, and it's up to you what masses you use. So again, these spring force sensors, or spring scales, the pulley, the string, and these masses are the things that you need for both parts B and C of the lab. So again, you got the cup with water, the index card, the other glass, part A, springs, pulley, string, and masses for parts B and C. So let's just quickly look at what we're going to do. Here's the pre-lab. This here talks about what the setup that you're going to have for part C, the very last part. It's known as the Atwood machine, but you're going to be using an experiment with different masses and a string over a pulley, okay? But going on here, part A is the experiential part. I already pretty much explained. You'll walk around with a glass of water and also do some experiments with the note card and putting masses on top of that, all right? There's some analysis questions for part A. Part B, again, it's a little weird. We do Newton's first law, then third law, then second law, as the lab sort of increases in complexity. But for the second law, again, I have you get a couple different scales, and then I have you do various different things. So the instructions are pretty straightforward on this part, but just to give you an idea of some of the things you're going to do, you'll hook the spring forces together, pull, and see what force they each measure. Try pulling harder on one and harder on the other, kind of see what you get. You'll just play around and make some recordings and observations of what you have going on. Then you might go and you might hang a given mass from one force sensor, measure what it says, hang it from the other force sensor, hang the two together like this, see what they each read, all right? You'll even take them and using the string, you'll hang one on either side of the pulley, the two different force sensors. So again, you can hang one on this side, put the mass on the end, hang the other one from the other side, hold it up, and see what they read. The instructions kind of lay it out, so I'm not going to go into great detail. And there's even a picture to show you. But again, you're going to be doing various different experiments and recording what you see and whether or not it meets up with our hypothesis based on the theory of Newton's third law. And then for Newton's second law, which is part C, again, weird order, sorry, but you're going to create something known as an Atwood machine. All right, so I'm going to do sort of a small scale version of this for you all here, but you're basically going to take a string and you're going to want probably a longer string than this. The longer you have, the better. So if you could hang this, from somewhere where you have a good meter or two of distance, that'd be great. You could hang it just from underneath the table, but if you have more space somewhere to hang it higher up, from like a coat rack or even from a door frame, again, just get a piece of string, tie it around the top of your pulley, and tape it up to the wall or hook it around something that's sturdy and strong. But you'll have this set up, and then you're going to get two different masses. All right, so you might get a cup with one mass, this guy here. You'll hang it on one side of your Atwood machine. Let's get this hooked on here. And then you'll get a second mass. So you get a second mass and then you'll hang it from the other side. Initially, you'll want your two masses to be approximately the same to see what happens when they're the same, but then you're going to create two different masses. So the lighter one will be M1, the heavier one will be M2. Then you will make the lighter one even lighter, the heavier one even heavier, and call it M3 and M4 and do it again. So to show you kind of what that's going to look like, again, you'll be tying this pulley to a fixed surface. I just don't have a good fixed surface here in my kind of makeshift office, but you're going to get it set up so that they can move. You'll let it go. One will go down, the other will go up. I'd recommend using some smaller cups probably so that they don't collide. Or if you happen to have two pulleys, you can actually use two pulleys to separate them a little bit more. You don't want them hitting one another. You want them free to move. So you can actually use two pulleys instead if you want. Maybe I'll show you that here really quickly. One moment. So here, just to show you what it would look like if you chose to do two pulleys, I now have my two pulleys affixed. They're actually being held by my wife, but they're set in place, and now there's more space between my two masses. So if I go ahead and release this mass here, it will accelerate down while the other one accelerates up. Now, if you notice, the distance over which it's falling is very short, and you would have a hard time measuring that time very accurately. So make sure that you do this over a much longer distance, at least 1 meter, if not 2 or 3 meters. But that's the idea behind the Atwood machine. You're going to measure that distance, and you'll measure the time it takes to fall and use that to calculate the acceleration based on the two masses, which hopefully you did in the pre-lab. So that's a quick rundown on what you're going to be doing in Lab 3.